Good evening, everybody. Just going over a show from Blue Marble Science. And I mean the Blue Marble Scientist, the head of the Blue Marble Science. So here we go. Let's see what we got here.
Rate them.
Didn't Lemon Bird? The closest we got was Lemon Bird and Smushing, right?
Yeah.
Smushing.
I was going to do my lemon bird smushing and nushing, but you beat me to it. You have to whine. You have to whine when you have to whine. You have to whine when you say that, though. Smushing and good.
Yeah, and
So we start off right away with an exciting smushing and mushing. Shout out Lemon Bird. We haven't heard from you for a while. I hope you're okay, bro. So let's continue here.
and to respond to SE in the chat. Yes, SE, the Earth is not a sphere. The actual model that we use is an ellipsoid, and the ellipsoid does not have a constant radius. The radius is changing. We all know this.
Say what there, Blue? Did I hear you correctly? Did you say the Earth is not a sphere?
And as a follow-up, the oblateness is slight. So using the sphere is for navigation purposes, just fine. Using
Right.
it for the sphere for something of only a few hundred square miles, just fine. But when you go transcontinental or you're going on very long GPS, it's all slightly oblate, as measured initially in 1760.
Yeah, the Earth is an oblate spheroid. Therefore, you can't measure angles to build a house, a two-story house.
Well,
Right.
what he's pitching
I
a
heard-
shit fit about is the fact that the GPS data, XYZ data from Lake Pontchartrain clearly shows the change in the radius as you go from the north end of that causeway 24 miles to the south end of the causeway. The radius is constantly increasing, which is exactly what happens on an ellipsoid like the Earth.
I had heard that if the Earth was the size of a pool ball, that would be legal for tournament play. It's that.
all that stuff. But SE is trying to make a mountain out of a molehill here. He's bringing into question the fact that the radius of the Earth over that 24 miles changes about 340 feet. Okay, that's what it should do.
Did you say a mountain out of a molehill? Uh-huh. You just said, everybody heard him. He said, Lake Pontchartrain, the Rakia Bridge has a difference of 340 feet from the north side to the south side. You heard him, ladies and gentlemen. A mountain out of a molehill? I would say so. Uh-huh. It's quite a big molehill there, Bubba. 340 feet. Let's see what else we got.
And you mean mountain out of a molehill, literally.
On the Earth's ellipsoid, isn't the difference between the two radii about 24 miles?
Something like that.
No, specifically, that's the difference in the two semi-major axes. Because when you're talking about the radius, you're talking about the radius of curvature. And at the North Pole, the radius of curvature is much longer. It's 3970. Although that's on the ellipsoid, that's the B semi-major axis, which is shorter. But the center of the curvature of the meridian at the pole, that center point is below the center of the Earth.
Oh, okay. Well, as a percentage of the major axis, what is that like? It's far less
3%.
than 3%.
A couple percent. Yeah, 3%. It's nothing.
Yep. That's pretty small.
It's like the same thing with the orbit. You know, the orbit is slightly eccentric, like at 0.016 or 0016, something like that.
Yeah, orbits are elliptical.
Well,
Yeah, I believe.
You could figure out then the size of a cue ball or a billiard ball, and then calculate 3% of that and translate it into millimeters.
You could do that. And you know, the thing is, I have actually seen diagrams where you have like 4 circles, and one of them is the orbit of the Earth and slightly eccentric. And of course, you can't tell the difference between the two.
I believe we have the least eccentric orbit in the solar system. I'm not sure though. But I think that's true.
Yeah, I think you might be right about that. But here's the bottom line to it, SC. If I had shown you those XYZ that data from Pontchartrain, and all 3 of those radii were the same, then you would have reason to call bullshit, because the damn Earth is not a sphere. It is elliptical.
Not a perfect one. Yeah.
Take it easy there, Bubba. We don't want you to pop a vein or something. The Earth is not a sphere. All right, I get it. I understand. Jeez, okay. Message delivered. Man.
And even worse, it's
Laugh
not
all
a
you want
regular.
to, SC. You're making a goddamn fool of yourself. Keep doing that, and I will kick your ass out of here.
And even then, it's not a
That's what they
perfect
want.
ellipsoid. It's not a perfect ellipsoid. It's lumpy, right?
Well, we
Or-
use an
yeah,
ellipsoid model.
dimension.
We use an ellipsoid model, and then we modify it with a geoid model.
Okay.
Yeah, the geoid is orthometric. It does have variation in the vertical called the deflections, the psi eta components. Yeah, those are minor. Those are in arc seconds. They're minor. So the ellipsoid, the WGSA4 ellipsoid, is the mathematical description that's a best fit of the total volume of the planet.
Yep.
You heard the blue marble scientist. You get an ellipsoid model, and then you modify it to a geoid model. Sure, everybody understood that, right? Alakazam, alakazoom. Done.
It's complicated, and there's no apology for that. But it's only complicated when you're looking at the high detail and high precision. Because if you're on a fucking sailboat or a cruise liner, it doesn't much matter. You can use the Haversine and a 39, 60-mile radius, and you're not going to be off, but hardly twice the length of your ship over any great distance. I mean, the scales. They got no concept of the scale of when you're dealing with arc seconds, and then going 800 miles. You're still not going to, completely screw up your navigation. But in geodesy, that shit matters. And it matters a lot. It matters obviously. It jumps right up and bites you in the ass.
There you have it, ladies and gentlemen. Blue Marble Science and the Blue Marble Scientists. What a spectacular show. I enjoyed it, and I hope you enjoyed it as much as I have. Thanks a lot. Thanks for tuning in. Have a good day. Ciao.